Hello everyone. Please accept my apologies for switching to a recorded video lecture in the last minute. Before we dive into today's lecture topic, which is going to be on objects and references, we are going to do a quick quiz. And we have 3 different questions as part of this quiz. Let's get started with question A over here. So question A is asking, what is the type of the following variable? So if I make an initialization with just empty curly braces, I'm going to give you a second for you guys to think about this question. The options here are option 1 set and option 2 dictionary. So if you thought of your answer to be option 2 dictionary, then your answer is correct. So recall that if you want to initialize an empty set in Python, you need to actually call the set function, which is going to instantiate an empty set for you. And if you just initialize a new variable with empty curly braces, that's going to create a dictionary. Alright, so let's move on to question C over here before looking at question B. So question C is asking which of the following types is immutable, and the options here are option 1 string, option 2 list, and option 3 dictionary. Alright, so if you thought of the answer to be option 1, then you had the right answer. So strings are immutable, whereas lists and dictionaries are mutable data types. Alright, so let's move on to question B, which is sort of tricky when compared to question A and C. So let's take a minute to actually read this question slowly. So the question is suggesting that there is a string S and there is a list L. You don't have any other information about exactly what is stored in the string or what are the items which are stored in the list. Given such a background, which of the line is definitely guaranteed to fail? And your answer options are option 1, s of -1 equal to string period, and option 2 here being L of length of S is equal to being string. I'll just give you a couple of seconds to think about this. Alright, so the correct answer to this question is actually option 1. A lot of students actually think that the answer for this question is option 2, but that's not correct. So let's take a look at why option 2 is guaranteed to fail. The hint sort of comes from question C, right? So I just now told you that string is a data type which is immutable. So anything of the form string of index equal to something is going to be invalid because you cannot mutate a string. So in that same respect, option 1 here is definitely going to fail. So let's take a look at option 2 here, which might or might not fail. So let's consider the scenario where option 2 actually fails. So suppose your string S contains a string which has 100 characters, and suppose your list L contains only 3 items, then any access of the form L of length of S, which is going to be L of 100 equal to something, is going to fail. That's because your index 100 is not defined as part of your list, so you're going to get an index error if that is the situation. Let's take a look at the case where it will actually not fail. So let's switch the scenario around, and suppose if we consider that the string has 3 characters and the list has 100 items, then this particular access is assignment is trying to set L of 3, which is going to be the 4th item of your list, which is actually defined. So you can go ahead and reassign the 4th item in your list value to be whatever value is present as part of your string variable. Alright, so moving on to today's lecture topic. Today we are going to be talking a lot about objects and references. We are actually going to be discussing how to create custom data types, which is quite exciting. Uh, Let's get started with the concept of objects and references by using this diagrammatic representation that we used as part of the last class worksheet. So recall that we had a snippet of code which defined few dictionaries and few lists, and all of this confusing structure was represented using this neat diagram which we used to learn how to index into each of these, right? So today we are going to talk a lot more about how the representation for the variables and the data types occur as part of this diagram. So when it comes to objects and references, all that we need to care about these are these arrows. So what is an object? So whatever is being pointed to by the pointy end of the arrow here, the arrowhead, is going to be an object, and whatever is from the place where the arrow is originating, which would be at this end, that's going to be called as the reference. So let's talk about a few observations here that we have. So the first observation that I want to talk about is that objects sort of can have a life of their own. So what do I mean by that is, let's take a look at an example of these two lists, for instance. So as you can see, there are no references as part of your frames which have like direct access to these objects, right? But those objects do exist. So that's sort of going to be an independent existence for these objects. And another thing that I want to point out is that objects reside in a place which is called as heap, sort of like a collection of all the data which is there as part of your objects, whereas your references exist as part of something which is called as the stack. So as we have observed and spent a lot of time on this part of the mental model over here, whenever you get a function call, a new frame gets created and sort of like gets stacked on top of the existing frames, right? And then when a function call gets the execution gets done, that particular frame disappears and gets removed, hence the name stack. All right, so another observation that I want to make a note of here is that this particular example has two different data types, which are dictionaries and lists, right? We have like three different lists and two different dictionaries, but many other data types are actually possible, including custom data types, which we'll be talking about today. And the final observation that I want to make is that your references can show up in two different places. One is part of the frame itself where a variable exists, or the reference can be as part of your data structure, which would be this example where you have like a list object being referenced from a key in your dictionary over here. Alright, before we talk about the questions related to objects and reference, I just want to point out one thing about Python. Uh, Technically in Python, everything is actually an object, which means that even integers and strings are actually objects. So the correct way of representing this particular diagram for the code would be if you had the arrows from the list position pointing to the objects which are represented by integers or strings. As you can see, this can get quite messy quite easily. So we can sort of like not have this complicated structure and use the values directly inside the list and the dictionary. Alright, so we might be wondering why exactly we need this more complicated model, considering that we've been able to write and be successful with writing Python code without having the need to actually think about objects and references. So we are going to be discussing that. And we are also going to be talking about how to create our own custom data type for objects. And one thing we have seen so far is like we can use the double equal to operator to perform comparisons between two different objects. For instance, you can just like compare two different lists by saying like L is L1 if L1 equal to L2. So that sort of gives you the option to compare objects. So we are going to be talking about how to compare the references itself using an operator called is. And we are also going to talk about how to create copies of objects. Alright, so the first thing that we are going to cover as part of today's lecture is a new data type called tuple. So there have been a lot of questions about tuple as part of this class. A few of them have asked like, can I initialize list with parenthesis instead of using square bracket? That would create a tuple for you. So getting a grasp of tuple here is going to be quite simple if you have a good grasp of how list works. So if you replace the square brackets as part of your list initialization to a parenthesis instead, then you're going to get a tuple. So let's take a look at what is the similarities between lists and what is the list and tuple and what's the difference. So tuple is kind of a sequence, right? Similar to a list. So we are going to be able to do all of the neat sequence operations like, okay, iterating over the sequence using a for loop. We can index into a tuple and we can slice the tuple, and all other sequence methods are in general applicable, including length of a tuple and so on. So what's the difference between a tuple and a list? So unlike the list, tuples are actually immutable. So that's something which is similar to a string. So you can have any different types of data as part of your tuple similar to a list, but the only restriction being you cannot actually mutate the tuple. So let's talk about what mutation operations are. So for instance, if you just try to index into the list, an example here being the num list containing the entries 200, 100 and 300, and we have the similar counterpart of num's tuple with the same entries. So you can index into each of those types by saying num lists of 2 or num tuples of 2, both of which is going to return the value 300, which is going to be stored in the variable x here. So let's talk about the mutation operation. So using lists, you can say things like, okay, nums underscore list of 0 equal to some other new value, whereas with tuples you can't do that because keep in mind that tuples are immutable whereas lists are mutable. So you might be wondering why exactly do we need a tuple, considering that it seems to be a worse option for a list, having all the list features but not having the options to mutate the values. So there are two different reasons why we can use and need a tuple here, for instance. So the first reason for using a tuple as opposed to using a list would be, suppose you have a data set which you never want to modify. For instance, let's consider the hurricanes data set. Hurricanes are events which have happened in the past, and it's not likely that you would ever need to modify the amount of damage caused by a hurricane, or let's say the number of the year in which the hurricane actually was created, or like the amount of impact it had, right? So that could be one such scenario where you would need to use a tuple instead of using a list. The other scenario, for instance, would be that you would actually need a data type like tuple for creating a particular data type that you're interested in. For example, let's just take into consideration that suppose we want to create a dictionary with key as location, let's say latitude, longitude values, and values as the name of the building that that particular location points to. If you try using a list as a key in your dictionary, that's going to fail with an error saying type error unhashable type list. For now, just try to equate the term unhashable to refer to the fact that you're using a mutable type as a key. We are not going to be able to cover hashing as part of this particular course, but you can just like imagine that you have uh, your list data type as a key, which can potentially be modified, so that's not allowed in Python. So how do we actually achieve this goal? The way that you can fix this problem is by using a tuple instead of a list, and now your dictionary instantiation will actually succeed without any errors. All right, so let's do a quick recap of all the parenthetical characters and the overloading that we have covered so far. So, quick recap: overloading refers to the fact that a same character or a function name could be used for multiple different meanings, and the meaning will sort of depend on the context that you're currently referring to. For instance, for the parenthesis, we have covered three different types of usages so far, right? So the first one being how to specify a specific operator precedence order if you want to override the default precedence, and the second one being for function definition or function invocation, and the third such usage is by instantiating a tuple. So there are sort of like corner cases here with respect to the order specification and the tuple usage exactly, right? So how exactly do you know this one is the order specification, and whereas like it's why is it not a tuple? Why can't it be a tuple of just length of 1? So the way that the Python is going to differentiate between just or precedence, parenthesis and tuple is by the fact that a tuple of size 1 is usually represented with a trailing comma. So recall that in Python you're actually allowed to add a trailing comma for a list or a set. Similarly, for a tuple also you're allowed to add a trailing comma. That's how Python is able to differentiate between tuple of size 1 and the parenthesis used for operator precedence. All right, so uh, we have covered talked about the data type tuple. We are going to move on to talk about something which is called as name tuple, which is going to enable us to create custom objects and custom data types. So I'm going to motivate this with a couple of examples, and then we are going to see why exactly we need custom objects. So I'm going to leave this slide up for a minute. There are like two versions of code over here where I have a list of people, and I'm just like trying to access one of the entries in my list, and I want to print out a few details about the person. So the first version actually uses dictionary to represent the person's data, whereas the second version uses a tuple to represent the person's details. Both of these versions actually have a bug. I'm going to give you a minute to actually look through the code and try to spot the bug by yourself. Alright, so let me go through what was the bug in the first version. So I'm sure most of you noted that the F name over here is actually, the F name key is capitalized, whereas what I'm trying to access is the small case key using small F name. Whereas the bug with the second tuple based representation of the same data is the fact that I'm sort of uh, trying to concatenate both a string and integer type without typecasting. So p of 1, let's see, people of 1 is going to point to the second tuple over here, p of 0 is going to be Bob, p of 1 is going to be Baker, whereas p of 2 is going to be 31. Perhaps what here is how we can fix the issue with the with both of these bugs. Instead of having capitalized F name as a key, it should be actually small f name. And similarly, instead of trying to refer to P1 and P2, perhaps I meant to concatenate P0 and P1. Sort of difficult bugs to catch in the in terms of figuring out what exactly went wrong, right? So unless you get to the point or get to the stage where you actually use this particular key, you wouldn't be able to figure out that okay, there is a typo with that key. And similarly, unless you pay close attention to which index you're using in your tuple, it's quite difficult to read this code and understand that you actually meant to take the first name and last name of the person from the tuple, which sort of creates this motivation for what if we are able to create a custom type where we can just define the fields one time, and we'll be able to instantiate any number of objects by mentioning that particular custom type. That will be very useful, right? So it can overcome both of these issues, sort of. The first one being like you want to define, keep defining multiple dictionaries over and over again. Even if you try to use the same key, you might end up with a typo at some point. Or as with the second case, you don't really want to be using indices to access the data, because it's often very difficult to remember what index refers to which type of data. Alright, so that leads us to the third different option here, which is based on name tuple. The way that name tuple works is it will enable you to create a custom data type of any type that you would like to. For instance, here we are trying to store information about a person, right? So let's say we want to store first name, last name and age. The way that you can create a new data type is by invoking name tuple and saying exactly what the name of the data type that you're trying to create over here. That will be the first parameter, which is going to be a string, and the second parameter to your function is going to be a list of all the fields that you're interested in creating for this particular data type. So these fields are often referred to with the keyword name as attributes. So a particular instance of this particular data type is something which is going to be called as the object for this particular data type. So by calling this function, you are creating a data type of the type person, and then you can go ahead and instantiate that particular data type by creating a new object using the person call. So you're going to be using the data type name and a parenthesis, and you're allowed to use the values for the attribute for that particular object. So I'm going to be discussing this example in detail in the upcoming slides. Perhaps you should consider revisiting this example once I go through the next few slides. Alright, so let's focus on all the important points from the option 3, which is sort of like a combination of both the worlds. So name tuple is coming from the module called collections. So it is essential that you explicitly import name tuple from collections in order to be able to invoke the name tuple function to create a new data type. So let's focus on this function call again. So what we are saying is the variable to the left is going to be the name of the type that we are interested in, and a name tuple means that we are trying to create a new data type, and we repeat the name of the type as the first parameter, and then we mention a list of all the attributes that we are interested in for creating this particular data type. Alright, so why do we have to actually mention the data type that we are creating twice? So the first one is actually for creating an object instance of that particular type. Python actually allows you to vary the description over here, which is going to be the text that's going to get listed when you do type of person. So typically both of these descriptions should be the same, unless you want to give a specific description for the type function call, then you can type that over here. So couple of things to notice about the attribute names. So the attribute names, even though they are just strings, they cannot be like any default string, and they need to follow all the rules that variables in general are expected to follow. So you can't have things like space as part of your attribute name definition. Alright, so let's get into the details of what exactly name tuple is enabling us to create. So before that, let me quickly talk about what data types we have covered so far. So we are aware of the fact that integer and float are two different data types available to us. Both of those are coming from number. Similarly, we have seen few examples of sequences where like you can have a string, a list, a set or a tuple and so on, right? In a similar sense, name tuple is going to enable you to create a custom data type. For instance, I can create a data type for person, or a data type for hurricane, or a data type for a player, and so on. Alright, so let's focus on how to create instance of object of the data type that we just created. So the way that you create instances by using the name of that particular type that you just created, and then you pass the arguments to the attributes. So there are a couple of ways that you can pass arguments to the attributes. Before I talk about that, this particular function call is going to return to you an object instance which is going to get saved in the variable p over here. Alright, so let's talk about how to pass the attributes. So the first way to pass the attributes is you can use the positional way to pass the arguments into the attributes, which means that each attribute goes into, each value goes into the corresponding attribute as per the listed order. Or you can do things like you can use the named keyword arguments, in which you can actually switch around the order, and you can mention your values in any order, provided that you have an attribute name defined for everything. Let's talk about what would happen if you used the incorrect attribute name over here. The difference between the previous version where we use the dictionary and this one is that Python will immediately crash, and it will complain that okay, this particular attribute is not defined as part of your custom data type person, which is good, right? So we don't have to wait until we actually use the that particular data to figure out that something was wrong or we had a typo. All right, so let's talk about how to access the values of the attributes given a particular object. So just a quick recap, as I mentioned, the object here that gets instantiated when you invoke the person function is going to go into the variable called p, And the way that you're going to access attributes is by using the dot operator. You're going to say p dot attribute name, which in this case would be f name or l name or age. So this access is sort of similar to what you do with the dictionary, excepting that instead of using square brackets, you're going to use the dot and you're going to use the attribute name. So once again, you cannot have spaces or things like that as part of your attribute name, because the attribute name needs to follow all the rules that Python variables usually have to follow. Alright, so let's talk about the second custom data type, which is going to be based on record class. So the difference between record class and name tuple is actually quite simple. Both of it serve the same purpose of creating a custom data type. So what's the difference? So name tuple is actually immutable, whereas record class is not immutable. So let's take a look at an example over here. Suppose we have a person defined as part of the person data type defined using name tuple. So if you want to increase that particular person's age, considering that age increases every year, that's sort of going to give you a problem, because name tuple is immutable. Whereas if you take a look at the corresponding implementation using record class, you will be allowed to change the age attribute of that particular person, and luckily the person information can be updated and they can actually have a birthday to celebrate. Alright, so record class is going to be similar to name tuple. You're going to import the module record class from record class, which is sort of like weird. You have to use the same keyword both for the module name and for the for the function call itself, and the way that you're going to create a custom data type is by using the keyword record class itself. Alright, so what's the difference between name tuple and record class is that record class is not actually installed by default, so you'll have to do a pip install of record class to be able to actually use it. Alright, so moving on, so far we have discussed all about objects, right? So we spoke about the new data type tuple, and then two different data types called name tuple and record class for creating your own custom data type. So one thing that I want to emphasize is name tuple and record class actually enable you to just create your own custom data type. You can't create a data type called name tuple. That doesn't make any sense, because it's there only to enable you to create your own custom data type and objects corresponding to those. Alright, so let's move on to talking about references. So the first thing that I want to do is do a quick recap of the mental model that we have seen so far for the state of a variable. So suppose you have a simple snippet of code over here where the variable x has the string hello and y has y equal to x, and then we add on the string world to y. So the way that we have been seeing it so far is like you have a box for x and hello goes into that, and then you have a box for y and hello goes into that, and then you add on the world substring to the box and y, right? So what is lacking with respect to this particular mental model is that it's actually not correct for mutable types, and it also doesn't take into consideration performance in order to represent exactly what's going on over here. So let's look at version 2 over here, which is actually the more correct version. Let's go through the same example, and this time we are going to have a separator for the objects and the references, the right side being the heap and the left side being the stack. So what happens when you create a reference x to point to the object hello is that you have a box for x, and then you have an arrow pointing from x to the immutable string hello. And then what happens next is that when you create y equal to x, it actually creates a copy of the reference, and y now points to the same immutable string hello. Let's talk about the last step over here. What exactly happens is when you append a new string, substring to y, it sort of creates a whole new string called hello world, and y is now going to point to that particular string. So whenever you are making modification to the reference itself by saying you want to add on another sequence or like another new reference to part of it, every time it creates a new object in your heap. Alright, so we are going to be seeing other examples of this shortly, so that will be more clear. Alright, so let's do a quick recap of assignment and argument passing rules. So recall that whenever you do an assignment, let's say you're assigning some value to x and then you're saying y equal to x, what exactly you're saying is that y should reference to whatever object value that x references to. Similarly, whenever you're passing an argument, let's say in your global frame, you're just instantiating a variable called x, and it's pointing to some object, and you're calling the function f over here with the reference x. Whereas in your parameter definition, you have your parameter defined to be y, then what are you saying there is that y should actually reference to whatever object that's being referred to by x. Hopefully that makes sense. Alright, so let's talk about the same example from the perspective of Python Tutor. So recall that during the first few lectures, I actually spoke about the different options in the live programming mode, which enables you to either look at the inline primitives, which is the default option, or you can actually render all the objects on the heap, which is sort of going to be the actual representation which Python uses. So the difference between the two, you'll just use boxes for the inline primitives, whereas the heap version actually uses the arrow between references and objects. Alright, so let me talk about why exactly we need this new mental model which involves references and objects. What was wrong with the previous mental model that we actually had, and why can't we just like write programs following that? Right. So the reason for that is because there are twofold reasons. The first one is that the old model doesn't take into account performance. So what exactly do I mean by performance? Let's take a small snippet of code here. For instance, suppose we have a string variable x defined, which has a lot of characters, and we are saying like y equal to x. That particular snippet of code runs quite fast in Python. So the reason for that is, as we just saw, when you do the operation y equal to x, you're just saying Python that okay, I'm creating a new reference y, but it's still pointing to the same object in the heap. So you don't actually copy the whole object over, so that this particular code is going to be quite fast. This wasn't considered as part of the old mental model. Alright, so the second reason for considering the references and objects sort of model is because you can actually make centralized updates. So what do I mean by that is that there could be multiple references pointing to the same particular object, right? So for instance, suppose we create a person using the data type person that we can create using record class over here, and we instantiate the person type for a player called Alice, and then we give Alice a score and a age, and say for another person, player Bob, we create another instance with the corresponding score. And let's say we have a function which sort of can compute who among the players is the winner, and let's say you make an assignment saying, okay, winner reference is the same as Alice by doing winner equal to Alice. So in that particular case, if you try to make any modifications to the Alice reference after assignment to a copy of that object, you can actually see that now the winner's age will also automatically get reflected. So the way that this works is, let's take a look at the mental model. So Alice points to the object that we created, and Bob points to the object that we created when creating the object instance. And what happens when you create winner references, that it only points to the same object as Alice points to. And when you do Alice dot age plus equal to 1, winner dot age also gets updated because it's pointing to the same object in the heap. So eventually when you print winner's age, since Alice had a birthday, that's gonna get reflected, and you're going to see 31. All right, so let's talk about a little bit about bugs before we talk about comparison between two references. So let me actually switch to Python Tutor for this demo. So I'm going to go ahead and copy paste this particular snippet of code. I'm going to Python Tutor. Alright, so let me step through from the first here. Before doing that, recall that if you scroll all the way down, you can switch from the default inline primitives to say Python to render all objects on the heap. I'm going to go ahead and switch that, and let me step through from the first. So alright, so we have a function f over here which is just taking in a parameter x, and it's just trying to multiply the value argument value by 3, and it's trying to print that. So let me go ahead and run the program, step through it. So we have a variable num defined as part of the global frame. Observe that it's actually using the heap representation to point to the object integer object 10. So num is your reference, 10 is your object which is on the heap, and when you call your function, what happens now is that you get a new frame, and the reference x actually points to the same old object 10. But whenever you're making modification to the value of the object itself, notice that it's creating a new object. It will be so confusing if Python actually replace the value of 10 without creating a new object, right? How can 10 all of a sudden become 30? It sort of makes intuitive sense that Python had to create a new object because integer is immutable. Alright, so what happens after that is we go ahead and print 30 and then we return. So observe that the value for the object which is pointed to by the reference num doesn't change. So you're going to get a value of 10 after that. So these code snippets are actually from the interactive exercises which is posted as part of the course website. Please step through this on your own pace to try and understand this in detail. Alright, so let me move on to the next example, which is slightly more complicated. So as you can see, with the list, actually if you use the heap based representation, it gets trickier and trickier. So I'm going to for now go and change this back to the inline primitives, but you're welcome to explore this later on. Alright, so let me go through the code. We have a function f here which is supposed to take a list, and then we are doing some manipulation, right? So let's step through the code from the global frame this time. So we have a list called words, and the list contains two items, hello and world. And then we are invoking the function f over here, and we are saying to the function we are passing the parameter words. So recall that function call is going to make items now get a copy of the object which was pointed to by the reference words. So your items reference is going to point to the same object which was initialized as part of your words initialization. So let's talk about this particular operation, the append operation. So the append operation here is actually going to modify the object itself. So let's take a look at what do I mean by that. So whenever you have an operation which is supposed to modify the object, your reference is not going to get any modifications, and what's going to happen is the original object is going to get modified as such. So let me talk about what operations are actually part of the object modification. Suppose you have a list whose particular index you are trying to modify. The index axis is going to be object modification. For instance, if you say things like items of 0 equal to something, that's going to modify the object value. So your reference is still going to remain to point to the same object value. So if you just print try to append these three exclamation mark, it gets added as a new entry as part of the same object list. And what happens when you print items is that all three items gets printed. And similarly, when you return after the function call, you'll notice that the words reference also has the updated list. So that's because focus on the fact that we are modifying the object here and not the reference itself. So let me go ahead and go back to the slides, and I'm going to show you how to modify the reference. So the difference between this example and the previous one is that we are saying items equal to items plus and a new list. So whenever you do this, whenever you add two different lists, Python is going to create a whole new object. So that's the same observation that we had from the previous example a few slides back. Let me switch back to that. So for okay, yeah, so that's what happens in this particular slide. When you say x equal to hello and y equal to x, and if you're saying y plus equal to a new string sequence world, observe that it creates a brand new object as part of your heap over here. So let me go ahead and switch back to the slide, and let's take a look at the example over here. Alright, so if I step through this example from the first, you'll see that for words an object is getting created with those two items. So what happens when you step into the function and try to add this new list to the old list is that Python actually creates a whole new object, and now your items is going to point to the new object that you just created. And if you just if you try to print that inside the function, that's going to print the updated brand new object. And if you get back to the global frame, you'll notice that the words reference is still pointing to the old object over here. So try to step through these examples slowly so that you get a clear understanding of what's going on over here. Alright, so let me actually skip the next two slides. I'll let you figure out how to go through these two examples which are on sorting. Alright, so let me quickly talk about how to compare references. So far we have used the double equal to comparison, which is sort of the comparison for objects. So let's take a look at an example over here where I have like three different variables. Couple of them point to the same list, which is like x and y, and then I have a fourth variable which is sort of like created as an exact equivalent to another reference. So let's go ahead and take a look at a few of those comparisons. So when you do the comparison between W and X using the double equal to, clearly those two lists have nothing in common, so that's gonna fail. So when you try to check whether Y is same as Z, it's quite obviously true because you actually assigned the value for Z directly from the value from Y. So both are same. So what happens when you compare X and Y? Those actually are two different objects in your heap, but they're still the exact same list. So this operation is also going to return true. So let's take a look at how to compare the references itself. So double equal to enables you to compare objects. So is operator enables you to compare the references. So by saying is X is Y, you're just asking if those two references point to the exact same object in the heap. This is going to be false because they point to different list objects. Whereas when you say is if Y is Z, that's gonna return true because they are two references pointing to the same object in your heap. So often you would want to use the double equal to comparison, and it's very less likely that you would need the is operator for comparison, but you should definitely know how it works. Alright, so let's see, let's make a modification to the Y list, and if you try to print Z, what would happen is that when you're appending a new entry into the Y list, it automatically reflects on the Z reference because both are pointing to the same object. Unless you explicitly update Z to point to a whole new object, both are going to give you the same output over here. Alright, so the last note that I want to leave as part of using is that you need to be quite careful as to how Python handles this. So the reason for that is sometimes Python sort of can deduplicate equivalent values and make both references point to the same object. What do I mean by that? So let's say you have a string that you're trying to create using by multiplying 10 times, and you're trying to assign the result to two different variables A and B. So clearly the first comparison here is going to be true because you're trying to check two string objects which are exactly equivalent. So you would think that A is B is going to return false to you, but that's not often true because for the sake of performance, Python might deduplicate both of these and have like a single object which is pointed to by both of these reference, and in this particular case this actually does return true. Alright, with that I'll wrap up this video. Hopefully you can come to Wednesday's lecture with any questions that you have.